light.
Okay, green light. So we are very glad to have Florian here with us. He's a founding engineer at Gina AI. He's also consultant for European Commission. He's an expert in agentic AI, synthetic data generation. So please welcome Florian Hönicke.
So today's talk will be about Agentic Search, and actually I would like to empower all of you to build your own Agentic Search system at the end. Because these things sound a bit complicated, but at the end it's relatively easy, and almost all the code you need will later fit on one slide where I show you the Python code, which is usually showing code is not a very good thing to do in presentation, but we are the Python conference, so we will go through a small piece of code later together. And first, I would like to introduce you a bit about the company I'm working at. I work at Gina AI. We were founded almost 5 years ago, and they joined when we were founded. And since then, we contribute a lot of open source projects. So we started with a lot of infrastructure for AI code. Then this ChatGPT hit us a lot. And we're thinking, oh no, now you can just type in something into this large language model and it gives you the answer. Why would anyone even need search? Are we doomed? Do we have to do some totally different thing now? And now I'm very happy that actually search is needed more than ever before, because surprise, all the AI agents also search for things on the internet. Cool, more people coming. I have to say the front row is empty. There's no reservation on it, so please come here. There you. Let's welcome the additional audience. Okay. I just tell you a bit about our 3 main products we have. So we have this reader. So when you think of search, you might just think of this little search bar. You type something in and then documents show up. But actually there's much more to it that you have to build in order to create your search engine. So it starts with even getting the data. And then, so we created this program called Reader, where someone can insert a URL and then get even more people coming. All these places are free, so feel free to go here. Cool. So modern search engines work with AI, and AI is very bad in understanding these HTML format, this HTML content from websites. So we have this reader product that converts a website into LLM readable format, which is just great. It can read markdown format much better than looking at all this CSS and all these tags from HTML. And it's an essential part of search, because that's where everything starts, with the data. So then the second thing is, who heard about embedding models before? Okay, it's a very technical audience. I like that. So these embedding models are used in modern search engines where you convert a piece of data, for instance, a sentence, a text, into an embedding with this very special property that some semantic similar text is converted to a very similar vector. And then you can put this into a vector database and get similar documents. And getting similar documents to some query is very good for a search engine, right? And then there's another type of model that is less known by people. Who knows about re-rankers? Yeah. Like half of people who knew embedding models. It's a bigger model and more intelligent one that is used after the first retrieval step. And then you have this 2-step, or first retrieving a lot of documents, relevant documents with your embedding models, and then re-ranking them. But never mind, we don't dig into this too much, just want to explain what we're offering. Because today it's about how you build your own agentic search flow. And to give you a bit of idea where search came from and where it's going, I start with introducing you to about this journey. So it started all with keyword-based search, then we went to semantic search, and now the next paradigm shift is agentic search. And what did I just destroy? Okay. So in keyword-based search, this is all these old search engines, even in your browser nowadays, where you hit Command F and you want to search for something. It's only matching if it's exactly what you typed in. There's no room for any tolerance. And of course, you could add some equivalent semantic keywords, some synonyms to your database. So even if you hit a slightly different search term, then it also finds this relevant document. Okay, but this room of possible synonyms for text just explodes. And then if you even include how people could write something wrong, do spelling mistakes, it's just not feasible. And then you end up with people trying different search terms all over again until they find what they're looking for. And so one example where it works is this document, very tiny, but I explain you what it is. So query was best budget smartphones 2025. And then you get these documents where these exact keywords match. That's good. You get your document. But what if in your database there are different documents that describe the same thing, but just use different wordings? So for instance, for budget, we use affordable. Or for best, it's perfect ones. This year is 2025. So how could you even do this with this classical keyword-based search engine? No, it's not possible. Not easily possible. So we switched to a new paradigm back then to semantic search, where we use the embedding models and re-ranker models I described to you before. And with this, for instance, if someone queries for purchase Samsung and then gives certain ID of this model number, the exact one, because they saw it with their friend, want to have the same one, then yeah, you get this document, even if it's now buy and not purchase. You even get this with embedding models, very, very tolerant. The problem is the embedding model is also tolerant to other things like IDs. So when the embedding model decides to put in the latent space, put all the documents placed there somewhere, so they're nicely put apart from each other where they should be, then it ends up often to have this little corner of all the garbage input, or whereas IDs, where it just says, okay, this is an ID, this is also an ID, is very semantically equivalent because it's a random string of some numbers, which means you get hits you don't want to have. And for instance, it matches also this document where it's different ID, but for the embedding model, it's both ID is the same. And that's why people went through hybrid search. And hybrid means combining both of these strengths, combining these the keyword-based thing, where you can, for instance, have a price filter. This is my maximum budget. It should not be semantically around 10 euros or so. Or the size is also not can be more or less, or a bit, or a color or something like this. So you have these hard filters. But then you mix it with this semantic tolerance of the semantic search. And then even something would match. For instance, the query here is comparison of Google Cloud AWS pricing. Then you would find this one document that has gives an overview of all the pricing of Google Cloud Platform and AWS, and then also matches maybe product IDs you defined and everything. But this leads you to another problem that, and this is core of all this topic, because now we go towards agentic. So this is now the problem that this document doesn't exist on the internet, the one that describes everything you need. Instead, the information you're looking for is scattered around. It's in different websites. There might be even not one page that gives an overview over all AWS products, because they also have different sites. So we just have to now realize that it's not possible when making a single search query to get search result that answers our query. Instead we need multiple searches and then somehow aggregate the results to really answer all queries that could have been made. So now the new paradigm everyone in search is going to is agentic search. And yeah, in this case, it's now not retrieving only one document or a list of the top matching documents, but a list of documents that combined contain all the information that is necessary to give an answer. And what the next thing is, we don't know. I mean, I would assume next problem will be also looking for physical documents, where these AI agents cannot just find everything on the internet, but have to go out. But okay, this is too much sci-fi. We stick to what's useful for our work today. And to get started with, I would like to go for the most simple implementation of agentic search, because remember, I would like to empower all of you to later just write your own agentic search. Let's assume the human comes with a request, cheapest GPU with 80 gigabytes VRAM comes to our AI agent. We might define later also. But first, it's this friendly-looking robot. So this AI agent is now not directly asking the search engine cheapest GPU with 80 gigabytes VRAM, but instead it goes from first principles and first ask the question, what are even the GPU producers? It might have changed over time. Maybe since the model was trained, a new producer came, and this old knowledge is outdated. So it has to go always from first principles and find out about this. And then it gets back. It's NVIDIA, AMD, and even Intel is doing some GPU production. And then it already created some ground knowledge about this topic, and then extends its knowledge stepwise. So it goes with, okay, then let's go with NVIDIA first. What are the NVIDIA GPUs with 80 gigabytes? And then it will ask for AMD, and so on. And then step by step, collecting all the necessary information to give the final answer. So yeah, even at some point it reaches a level where it found out about all the GPUs, but now it's finding the cheapest one, and then finding all prices and price comparison. And it could do 100 search requests or 500 or something until it finds out final results. So now we actually define what this is, because I want to demystify these agentic search things and all these agents in general. And I like the meme from before, from the presentation before. And maybe it's also quiz time now, who remembered this part. So what is actually this friendly-looking robot? Who can demystify it? Or at least partially demystify? Anyone? And what could it be? Is it like really a robot? Or please, anyone? Python code, yes. Okay, we have the first component, Python code, then it's 3. Yeah, this was from the meme, API, yeah. You could also say it's a language model behind the API, yeah, language model. Vector database, I would say it's an add-on you could add. A human in the loop, it's an add-on we don't really need. But yeah, this is a nice point, could be. Okay, I think there's many more things, that's true. But to just get this thing run, probably is like, too trivial, but it's also a prompt that you need to write once. So code, prompt, language model. At the end, it's just code loop. So that's what we have, prompt, language model, and the code. So I don't want to make you read all of this. So this is a prompt, but I would like to give you like the feeling that it's not many pages of prompting and different types of prompt and so on. Just that you saw it once. So this is around the size of a prompt you need. And it starts with the general introduction. Yeah, you're this type of personality, okay? A user gave you this input, and then we insert it. So a prompt template. So we insert the user question. It should always keep track of that question, because that's what we finally have to answer. And then it gets another list injected for all question-answer pairs, all question and the answers that were generated before. At the very first step, it starts with no question-answer pairs because it didn't ask anything to the search engine. So we first have user input, then we have the empty list of question-answer pairs in the second. And then we tell it, please, language model, make one decision. You can either give already the final answer, and it would, if it's a question like, what color has the sky? If it's not like, well, the sky can have different colors and here and there, and it depends on the time. Then it's already saying blue without looking online for this to validate. But for most questions we would run, it would decide for the second decision, for the second type of JSON output, and it would generate a list of questions. So getting the user input, then question-answer pairs, a list of question-answer pairs, and at the end have to take a decision, should I output this JSON with a final answer, or should I output this JSON where it's a list of questions? And then, okay, language models, easy, take one of them. And now we go through our code. What you may realize already, so we have a while true loop here. So it's doing everything in a loop. That's what we want from the code. It's the most important thing, because we don't know how long it will run. Yeah, let's talk about this while true loop later. What issues this could cause. Okay, so very first thing we do is we format our prompt. So we have this prompt from before, and then we insert the original user query and also the question-answer pairs, which, remember, at first is empty. It's empty QA list. Then we make our LLM call. So yeah, maybe via API, or we have it local or whatever. So you have this, so this is not the code I show here, right? You just have your implementation of calling your language model, and then you call it with this formatted prompt. And okay, parsing JSON, not worth mentioning. Then the JSON could be two different things. So when we go to the slide before, it could have the mode final, or it could have the mode search. And then, depending on what it is, we either return the final answer, then we break this while true loop, or we go through all these search queries that the model generated, and for each of these search queries, we run a search. And I also didn't put the code for the search engine here because it's not about the search engine. It's when you have a search engine, then you call that search engine here. And enable your own search engine with agentic capabilities. And I think it's quite astounding that this is possible to just empower your existing search engine just by this code I show you. And yeah, then at the end, for each search query, you add it to your variable, this QA, the list of all question-answer pairs, so that in the next iteration of that loop, then the prompt contains all this additional question-answer pairs. And this goes on, and yeah, do you see already an issue with this when this runs for a very long time? Anyone?
Very expensive.
Oh yeah, it's so expensive, yeah. So we have a budget cap that we put for every query the user runs. And then when we see now certain token limit is reached, then we force the model to generate an answer now, or even generate you didn't know. And then another problem.
Maybe here you don't have any control, I think, on what document you are retrieving. So somehow you have to control what information are inside the document to guide your next search.
Yes, it can be untruthful, or it can diverge. So at some point we had the problem. We were typing in. We want a competitive analysis for our company. And then at some point it was finishing, and we were curious, okay, well, what is it saying? And it was saying, here is the chocolate you were searching for. And, it just diverged from all these question answers and to totally different topic at some point. Yeah, you have very few control what you find out on the internet, but that's also why it's so important in each prompt include always what the user originally searched for, so it doesn't lose context. But yeah, there are many more problems with this untruthful information and contradicting information and so on. So this is just the starting point I'm explaining here. You can go whatever. But yeah, okay, I give a small hint. So maybe you see an issue with all these question-answer pairs added to the prompt. And then I talked about 100 iterations or even longer. Anyone? Yeah, like your context explodes. It's just too much. When you think of the answer is all the websites in your search results, and you add them to your prompt. So we have to do something smarter. I mean, this works in theory already, but you will hit also some issues. So what we do now is, I always recommend to do the thing from before until you encounter an issue. So maybe there's just a single prompt that solves all of your issues. Then it's great. And it's also good, you can pitch already to your team or show others what you have built. They can give feedback and so on. But always the next step is to split up the prompt into smaller prompts that are very good in solving very specific tasks. So the thing I showed you before is now split into, when the user request comes, into one prompt that is just deciding for this for the next action. So is it a thing where I should give a final answer, or should I generate queries without even doing the query generation, because it's a very difficult part on its own? And then there's also one, if it decides, only one prompt that gives the final answer. And then there's one for query generation. If we have time later, we can also talk about this. It's not trivial at all, because the language model has so much bias built in. So even right now, for instance, when searching something about our company, it builds in so many assumptions about our company, how it was before ChatGPT, our branding there, but doesn't really question that we have updated or made a small shift, a different direction. And then there is this prompt we were talking about, that the summarization part, where you have like so much context and it grows over time, and now it's time to summarize. And out of this question and document list answer, just creating question answer pairs. And maybe some search results don't even provide the right results or are not insightful in general, then you can completely drop them. So you could also have a filter prompt and so on. And there's many more things we can attach. We can cache certain queries. So when I tell you, it always goes from first principle. And for instance, I ask about my company, what is our best products, or what are best products of Gina AI? Then it goes by first principle. What type of entity is Gina AI? And then it's, okay, it's a company. And then it asks a very basic question. You could also think of caching, where a lot of users ask these type of questions around a topic, then it will always be the questions by first principle. So yeah, so it's massive things we can do, but we want to stick to the very simple thing because it solves already most of your problems. And now it's time to look a bit into the use cases, because I would like every one of you to, while I go through this, also think about possible use cases in your own company or in your own work environment. For instance, something that comes up very often within the company is, what is our main competitor? And now there are certain things in agentic search flow could take over. For instance, finding previous analysis. Maybe there was something made a year ago, and maybe some of this knowledge is not outdated. This time, the agent is not asking a search engine on the public internet, but a search engine that is working on private data, with maybe your internal wiki or something, and then finds this report and can give better answer. But there's many other things, so it can also search online, what products do we offer, or also in internal documents, finding out where the market is, because only after finding the market the company is targeting, it can also find other companies that target the same market, otherwise not competitor. And yeah, many other things, but there are also certain things you don't want it to do, just randomly, like using other tool called sending email, or yeah, it cannot really talk to another colleague. Maybe you could just solve a lot of these problems by asking just one person, and then you outrun all the agentic search thing, because we're just humans, we can do a lot of things better. But this is good when you have massive amount of data in your company, and it's really nice to just tip and get a lot of insights, relevant insights for a use case. So okay, more use cases. Last year we had this technical problem. How did we solve this? To me, it happens a lot in my whole career. And then maybe you're lucky this one person is still working there, or maybe you're not. And then it's good if an agent can go through all this history, maybe archived Slack channels, or what else do we have? Internal documentation, error logs, reports, and so on. And then just tell, here is the ticket. Last year, this person worked on this, and this documented how it was solved in a perfect case. Yeah, then also what are the top complaints for our customers, understanding customers better, finding online all these places where customers talk about your own brand, and then get a nice analysis for this, or answer very specific questions. This is also often once you made an analysis, and then afterward, it took you a lot of time first, but then afterwards you realize, okay, actually we should have also asked this question. But then if you have your agentic search flow set up for this, you just ask another question about your customer, you ask it next year, and so on. You don't have to do the work again. There's a one-time work you made with setting everything up. So, and we can go with many more. And since I was in front of these slides when making them, and was thinking, okay, that's also a good use case. I was thinking maybe the same for you or for some of you, that you also think within your company something like this could be applied. And I would just like to, just 1 minute, talk to your neighbor, someone you ideally don't know, and just quickly explain them where do you think this could be applied in your company? 3, 2, 1, action. Okay, thanks a lot. Thank you. Oh, that was so great. That was so great to hear this volume, because it really signals me like every one of you had something in mind and really wanted to let go to your neighbor. So now I would be very surprised if there's no one who wants to share with everyone. Who could give their insight? Someone who would like to tell us where you think this agentic search can be applied to your company, where there is a use case. Anyone?
Finding information in the documentation.
What kind of information? So finding information in the documentation. So what kind of information is it? It's like, okay, it's just when you program me something or so?
The possible usage, not directly for a technical application, but like I know that HR units often need to search for CVs and match for example, specific skills or experiences to the specific role or a bunch of roles they're searching for. So these could be like
yeah.
Potential application.
Okay, so answer was from someone wants to signal me something. Okay, the microphone. I will just repeat the answer. So it's a use case where you can, where HR people can use such kind of tool to get insights into all the CVs. So they could even see, okay, we have the new job posting. How do the applications develop then over time? Do we have more of this type or that one? And yeah, that's true. So anyone else who would like to hear this?
So yeah, in my department, we work with plugins, and every time we develop a new project, we always have to scramble through previous projects to find something similar to what we're developing now. So an AI agent that was able to go through our shared folder and decompile all the plugin DLLs to find maybe with the prompt, with a really explicative and clear prompt, another project that maybe use the same communication protocol or the same structure would be really useful to have an example and to have an immediate feedback about what we're looking for and what we're trying to develop.
Yeah, I had the same when I worked at Deloitte, and then you have all these different automotive companies, and then for the next one, you're very curious what the other team for the same, almost same use case developed there. Yeah, that's true. Cool. Then just the most important key takeaway from all this talk, beside all the other things we also important, also what you said was important, is that this little robot is actually just this. These three things: it's a prompt, and it's a language model, and everything in a loop. Thanks a lot.
Thanks, Florian. We have 5 minutes for questions.
Hi, thank you for the talk. When you do the search part, how do you decide which search tool you use? I mean, you could even use your own agent when you do the search query, I guess.
So question is what search tool to use?
Yeah,
or
I mean,
search
do you
engine?
use your own agent search when the agent search does a search? Or do you use, I don't know, maybe Google API or something like that?
So the question is what search engine to use, right?
Yeah.
Yeah. So and Google offers an API where you can send in search term and then gives response like this or
Yeah,
something.
okay, but do you use your own agent search?
Yeah.
As in, the user make a search, the agent knows that needs to find new answers to more information, and that information is obtained using Google or using another agent.
Okay. So yeah, there is also an advanced concept of we heard also in our previous talk about multi-agent interaction. So
No, your own agent. So when your agent needs
Yes.
to do a search query,
Yeah.
does it use Google or does it use another instance of your own agent so that that question can be analyzed using an agent?
So
and
I
on
think
and on?
probably not, because we don't have this recursive thing of calling our own agent or so. So for instance, Google, but also others, we build an own search.
I was just wondering whether
Yeah.
if the searches that your agent does were done using, let's say, old-style search engines or another agent that would give
No,
different
no
information.
other agent. But it, for instance, can even write a MySQL query and then look in a database, and then this is a search engine. So just different search engines, one agent, that's it, no multiple.
Okay, thank you.
Yeah, thank you.
Other questions?
So thank you thank you for the very nice talk. So one question is that one input you have to decide when to stop, summarize, and go on, and that's a pain because all the benchmarks are not tuned for that. You don't know what is the retention of information in long context. So can you elaborate a little bit on this? If you see models getting smarter on long context and not just smarter on the LLM arena, so where it's very, very quick questions, and what is your rationale to decide when to cut the context, summarize, and go on?
Okay, when to cut the context summarization. So I don't really know if I understood your questions correctly, because so you're asking how we do evaluation, maybe?
Yeah, how do you decide, okay, let's cut it. Yeah, maybe how do you evaluate?
How do we do
if
evaluate?
So
Okay.
that's a parameter you say
Yeah.
that you learn from some evaluation when to cut. Is it a question?
No, we didn't learn from some evaluation. It's just really a budget cap where we say 1 cent we want to spend for user request, and then we count the tokens and we calculate how much money did we burn already, and then we don't know how big the search results will be, so maybe it's used up in a few iterations,
So you
and then
reach
we
the-
say stop.
But do you reach the context limit, or you say, okay, no, if I reach the context
when we
limit, this is not
summarize.
smart. I mean, OpenAI allow me for 1 million token,
I
but
see.
it's not smart if I go to 1 million,
No.
so I have to cut.
No, this is Okay, so yeah, summarization, I was a bit short today. So what we do there is we really create small question-answer pairs. So for instance, all of this. So the context should not grow incredibly large, because at the end it's just then what is price of NVIDIA GPU, blah, 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 and then it's just adding the price, and it's really just small and adding all this small information. So from this very big, noisy web page, it's really condensed to something very small.
Unfortunately, we have no more time for questions, but during the break, you can reach out to Florian. So thank you, Florian, again.
Thank you.